Hello, today we would like to give you a brief education on nanoparticles. Many have heard of nanotechnology, but not too many are sure what it is. The formal definition for a nanoparticle is any particle 1 to 100 nanometers in at least one dimension. However, a more practical definition of a nanoparticle is a small particle that exhibits certain and unusual properties. These effects are what make nanoparticles so useful because they allow known materials to exhibit new and useful properties. These properties can be used to improve almost any area of engineering. Carbon nanotubes can be used to strengthen and lighten concrete in order to make taller and safer buildings. Titanium dioxide nanoparticles use photovoltaic reactions to consume pollutants and make self-cleaning surfaces. Nanoparticles can also be used in water filtration. Carbon nanotubes can be used to make efficient filters, and superparamagnetic nanoparticles can be used to bond to heavy metals and then be pulled out of the water by magnets. These were some possible uses for nanoparticles in engineering, but let's take a look at a specific particle, gold.
The Romans used gold nanoparticles as a coloring agent in their stained glass. Gold nanoparticles can reflect many different colors. The smaller nanoparticles reflect red light, while the larger ones reflect blue. In modern day applications, gold nanoparticles are used for many things. In electrical systems, they're used on printed circuit boards to connect the different electrical components. In the energy sector, gold nanoparticles can be used as catalysts because they have high surface area to volume ratios. This is because if you have a 1 centimeter cube and you split it into 8 half centimeter cubes, then you triple the surface area. But if you make it smaller, on the nanoscale, you'll get many more times the surface area. In the medical industry, gold is being used in many applications because it's biocompatible. It is trying to be used for drug delivery. This here in red is the liposome with the drug in blue in the middle and the gold nanoparticles in green on the outside. The nanoparticles are used for keeping the liposomes from combining together. Now that we know a few applications for gold nanoparticles, let's see how to make them.
Nanoparticles can be made in two ways, from the top down or bottom up. From the top down, larger materials are made smaller until they're in the nanoparticle size range. From the bottom up, nanoparticles can be engineered or self-assembled atom by atom. Today, we will show you how to make gold nanoparticles using the self-assembly method.
Hi everybody, so today we are making gold nanoparticles using the citrate method. And this method, it has two reactants that we're going to use. The first is chloroauric acid, and the second is trisodium citrate dihydride, and you can also call that TSC.
So far we have 100 milliliters of 1 millimole chloroauric acid, and we're waiting for it to boil right now. But once it boils, we're adding 10 milliliters of 1% TSC.
Now our solution is boiling, and it's time to add the 10 milliliters of 1% TSC. And then in 5 minutes, we should have some gold nanoparticles. Okay, so now about 4 minutes has passed, and you can see our solution is getting redder, and that's because gold nanoparticles are beginning to form.
It has now been more than 5 minutes, and our solution continues to become more red.
So this is the second method we're going to use to make gold nanoparticles, and this is called the borohydride method. So we use two reactants. Again, one of them is the same as in the first method, chloroauric acid. And our second reactant is sodium borohydride.
This method doesn't require any heat, so we're starting off with 60 milliliters of 1 millimole chloroauric acid. And so we have a stir bar, which is all we need to mix throughout the entire process. And then we're adding 4 milliliters of 2 millimole sodium borohydride.
So you add it slowly as the stir bar is still going. The reaction happens pretty quickly. So as you can see, the sodium borohydride method definitely works a lot faster than the citrate method. But the downside to that is that sodium borohydride is pretty harmful to the environment.
In contrast, the citrate method, it is a lot slower and it requires heat, but it's not as harmful to the environment as the borohydride method is.
Sodium borohydride is also a better reducing agent than citrate, but citrate is a better stabilizing agent.
If you guys do decide to make your own nanoparticles at home, make sure you dispose of them accordingly. Treat them as hazardous waste because it could be harmful to the environment.
And also, if you do this at home, be sure to wear proper eyewear, gloves, and a hot glove like this to remove the beaker